our second speaker, so Alice. So just as a brief introduction, so Alice Ballerini, she's a postdoctoral researcher at the University of Modena in Reggio Emilia, where she works with Anna Bodano. So she's interested in clinical neuroscience and neuroimaging in epilepsy, and the main focus of her work is to better understand the structural patterns and connectivity networks associated with epileptic conditions, with a special interest on temporal lobe syndromes. So we're very excited to hear more about Alice's recent work, where I think she'll be presenting her work on subnuclear investigations in the amygdala and their implications for epilepsy. So Alice, please take it away.
Okay, I'm sharing my screen. Okay. Can you see it? Perfect.
Yeah.
So hello, everybody. This is so exciting to be here with you today. And I guess this webinar will be a good occasion for everyone to have discussion like this. So thank you so much for having me here today. So yeah, today I would like to talk to you about the amygdala and just brief introduction. So we all know that this tiny structure is located deep in the temporal lobe, and it's so important for our emotion and express our emotion, and especially for fear. But this is not the only the only human behavior which is involved the amygdala, because actually it's involved also in aggression or even in cognition, like learning and memory, and even in our social communication. So the question is, why is so important for our patients with epilepsy? So the main region, and because my main interest is in the temporal lobe epilepsy syndromes, is that the amygdala has gained a lot of interest in the recent year because of its role in this network. And this is because many studies find abnormal volumes of the amygdala that are related to the hippocampal sclerosis. But also, some amygdala enlargement has been proposed as possible biomarker for those patients who has a negative MRI. So if we look at the literature, there are plenty of papers from our colleagues about that, about amygdala in epilepsy or related to hippocampal sclerosis. But all of this paper consider the amygdala as a single entity. But actually, we have to consider amygdala based on on its morphological structures. And we know that amygdala is composed by different subnuclei, and each of them has its unique function and connection. So recently, some colleagues of us developed a tool for FreeSurfer, is implemented in the Dev version of FreeSurfer, that allow us to segment the amygdala starting from a routinely structural MRI. So through this toolbox, we are able to segment 9 different nuclei of the amygdala. And why this is so interesting? Because amygdala could be think about the amygdala like 3 different main regions, okay? Like the basolateral portion, the central medial portion, and then the cortical amygdala. Why this division is important? Because the measure of the inputs starting from the basolateral portion of the amygdala. So it's the primary target of cortical and subcortical input, specifically from the thalamus and the cortical sensory area. So from this part of the amygdala, the information travels and goes to the central medial amygdala, and then it's been projected to the hypothalamus and brainstem. This is useful for us because it's regulated our emotional expression, and specifically our behavioral and visual responses to fear. But even more are interesting the bidirectional connection that amygdala has with other regions of our brain, particularly with the prefrontal cortex, the orbitofrontal cortex, and then also the anterior cingulate, and the part that is interesting for us, the hippocampus and the entorhinal cortex. So these bidirectional connections are really important and involved in emotional learning, social behavior, and decision-making, but also in the regulation of episodic memory and the correct modulation of emotional responses. So how we can study the amygdala in vivo? So how we can study the amygdala? We can start from a routinely MRI protocol and then extract the 3D-T1s from the regular clinical stuff that our patients do, and then perform the classical pipeline from FreeSurfer that I think all of us are used to. And then we can run the Saijin and colleagues code, and then we can obtain 9 different volumes for 9 different nuclei in the amygdala. So why we have to do that? The first reason is that we know that amygdala is a key component of the TLE network, but most important, amygdala could be involved in some clinical feature, especially mesial temporal lobe seizures. For example, those sensation of fear can some patients reported after seizure, or memory with strong emotional content, the olfactory hallucination, and many of other autonomic manifestations. Another point could be that amygdala may be an imaging biomarker for those patients that don't have detectable lesion at the MRI. And last but not least, the connection that amygdala has with the brainstem and with the respiratory network may be useful for us when we evaluated the risk of SUDEP of our patients. So now I'm presenting to you a few studies that we done on the amygdala substructures, and the first one was done on 2 different groups of TLE, one with hippocampal sclerosis and the other one with a negative MRI, and we wanted to compare the volume of the amygdala subnuclei between these 2 groups, and of course a control population. So those patients were adult patients, and there was no difference in the age of onset between the 2 groups or in epilepsy duration. So the main outcome was this one. So as you can see, the pattern of atrophy is completely different between the 2 groups of TLE. While the TLE with hippocampal sclerosis showed global atrophy of the amygdala ipsilateral to the seizure focus, especially in the basolateral portion, so this part here. The TLE with a negative MRI showed an increase of volume in some nuclei, especially in the medial nucleus of the amygdala ipsilateral to the seizure focus. So these results told us that, yeah, amygdala is really involved in hippocampal sclerosis pathology, but also the subnuclear volume can help us to cluster our patients based on their etiology. And moreover, this suggests that amygdala could truly be an imaging biomarker, especially for those patients with a negative MRI. So starting from this pool of patients, this cohort of patients, we decide to extract just the left lateralized one. And we look at the correlation between the volume of the amygdala or the hippocampus and the cognitive performances of the 2 groups of patients. So as expected, the TLE with hippocampal sclerosis presented worse verbal memory scores when associated with lower volume of the hippocampus ipsilateral to the seizure focus. But also the amygdala showed up, and it seems to contribute to this poor performance in verbal memory. And specifically, the accessory basal nucleus and the cortical nucleus seems correlated to these performances. But when we look at the TLE with a negative MRI, the pattern is completely different once again. So in these patients, an increase of volume in the whole amygdala, especially in the basolateral and central media, but in the whole amygdala, is strongly related with poor performances in attention and processing speed. So probably the amygdala it's really involved in TLE cognition performances behind the emotional part, and also the amygdala morphometric features may be associated with different cognitive phenotypes. So after these two preliminary studies, we decided to look at the amygdala in a particular population of patients. So we collected focal epileptic patients with ictal central apnea. So people who have an apnea during a seizure. And we collected 16 patients, 12 of them were TLE. And as a control population, we collected 30 patients without this kind of manifestation, and of course, healthy controls. And the data are really interesting because an increase of volume, an amygdala enlargement in the basolateral amygdala, seems to be really involved in those patients with ictal central apnea. And we believe that this data is strongly led by the TLE group. So why this is important? Of course, we confirmed that amygdala play a key role in respiratory network, and also the basolateral amygdala could be a biomarker for this kind of patients with focal epilepsy, especially in TLE. But most important, because of this abnormal volume in the amygdala and the correlation with the apneas, this could be an important information when we evaluated the risk of SUDEP of our patients. So the last study I want to show you, actually, it's not directly related to the amygdala, but it's something important we found, so I want to show you. We explored 20 patients with a late form of TLE. So all of them as their onset after 15 years old, and really short duration. None of them has lesion at the MRI. Looked what we found, the same nuclei that were enlarged in younger patients. In this kind of patients seems to be atrophic. So I just put this to compare to you. So this is just a suggestion. We don't explore these results in detail yet, but what we can see is that it seems that the central medial amygdala and the cortical amygdala as well might present different pattern of atrophy based on the seizure or the age of first seizure. And maybe this could be related to the fact that late onset epilepsy maybe are different disease compared to youngest form. So, of course, there are still open questions here because I didn't check the frequency or the chronicity and the impact that they have on the amygdala. But I just wanted to show you these new results we got. So, few take-home message. Okay, we confirmed that amygdala play an important role in hippocampal sclerosis network. And also, we can suggest this region as a biomarker for those patients with no detectable lesion at the MRI. And of course, we need to look to the basolateral portion of the amygdala when we have patients with ictal central apnea, especially because of the involvement and the high risk of SUDEP of these patients. And maybe in the future, we can look at how the age of the first seizure could be related to different pattern of volume in the amygdala. In my opinion, there are future directions that we need to pursue. And the first one, we have to confirm this role of the amygdala in larger sample size. Due to the previous discussion, I agree we need more number, but of course we need to cluster our patients better. We need to have more clinical characteristics and information because there are a lot of features that could impact, for example, in this case, the amygdala. In my opinion, chronicity like duration of seizure and duration of epilepsy and seizure frequency could really impact the amygdala differently and in different ways. And another insight I want to highlight here is that maybe we need to explore behind the temporal lobe because of the strong relationship that the amygdala has with the frontal lobe. This structure could be really helpful even for other kind of focal epilepsies. So I would like to thank you, every one of you, and thank you for inviting me here today. It's really a pleasure. And check our website, become a member, and thank you so much. I'm stop sharing. Okay.
Thank you so much, Alice. That was a really wonderful talk. I can open the floor to questions. So does anyone have questions for Alice? Yes, Matthias.
Hi, super interesting, Alice. Can you tell us something about laterality, or you probably looked at ipsilateral and contralateral with your central apnea. Another way of looking at it is really left and right. And so this is something which we found when we looked at SUDEP. We did a very basic BBM analysis in SUDEP cases and high-risk cases. So there it was the right amygdala, which was bigger.
Oh, that's so interesting, because actually...
So this is Van Schneider et al. For 2015 brain.
So actually, so far, we had a really small sample size. So we look at the ipsilateral versus contralateral, of course. But if you have cases that you want to share with us, people who had documented central apnea, or of course, SUDEP cases, because we don't have none. I mean, in Italy, we don't classify them.
None of you have died. So, but that's again, actually, this is a brilliant idea for sharing. So yes, we have plenty. Well, unfortunately, we have plenty. Not plenty, but SUDEP cases who die under follow-up. Not necessarily all TLE, but the common thing is SUDEP here.
Yeah, because actually our suggestions are just because of the connection of the amygdala, but we don't have really SUDEP cases to compare with our patients. So that could be really interesting. Maybe let's keep in touch.
Yeah, and the other suggestion I would make is, I don't know whether Marian is on the call. So he looked at contralateral amygdala, and that's increases with time. So there's a whole story of an amygdala increases and increased amygdala over time. And the reason why this could be use dependent, compensatory.
Yeah, so far the findings are so specific. Sometimes there are enlargement, sometimes there are not. So that's why I think it's important to study the structure better. So maybe you have a question?
Yeah, yes. I think we have another question.
Sorry, I had to join late, so if I missed it, forgive me. It was a great presentation. You talked at the end about age for seizure. I work in pediatrics, so it makes me think, have you looked at this at all, or is the plan to look at this in kids that have epilepsy?
We don't treat kids in our hospital, so we don't have access to them MRI, but I think it could be really interesting. So in my opinion, if we can study children to older age, it could be the best way to study this process. But yeah, so far we only can deal with adult patients. So unfortunately not.
Thank you.
Any other questions for Alice?
Alice, can I ask you a very quick question, Emanuele from Pisa? Do you have any data on dysautonomia in these patients? It looks very interesting, this association with the apnea. And I'm very curious about any data on adult patients and dysautonomic symptoms in this kind of patients? Because we saw something similar in pediatric patients.
Oh, that's interesting. So yeah, because all of them were at our epilepsy monitoring unit. That's how we can say, okay, you have an apnea, or no, you don't have it. And so maybe we have, yeah, of course, semiotic of the seizure and other stuff too can correlate it with the other MRI information that we have.
Thank you. We are exploring the electrochemical scale conductance to find the connection between the temporal lobe structures and this kind of measurement of the peripheral autonomic function. It looks like there is some connection, but we have a few patients still now. Thank you, Alice. A very cool study.
Thank you.